Today, in this video, I am going to discuss about the unit and dimension of mu naught. I hope maybe all of you are familiar with this term mu naught. This one is called permeability of free space. In the previous video, already I have discussed about the Biot law. And you know, Biot law is always calculated for a small current element. And the formula for the magnetic field dB, this dB is what? Magnetic field due to the small current element is equal to mu naught upon 4 pi I dl sin theta upon r square. In the previous video, already I have discussed about this one here. This one is the magnitude of the magnetic field due to a current element by using the Biot law is this one here at distance r from it. This term mu naught upon 4 pi, this mu naught upon 4 pi is equal to 10 to the power minus 7 Newton per ampere square. It means the value of mu naught upon 4 pi is 10 to the power minus 7 Newton per ampere square. Be careful about this one. Mu naught upon 4 pi is this one. If anybody asks to you only mu naught, so mu naught is equal to 4 pi into 10 to the power minus 7 Newton per ampere square. And R, one more thing, remember this, R mu naught is equal to 4 pi into 10 to the power minus 7 Newton per ampere square. Please all have to learn this value. Be careful. Only you learn mu naught upon 4 pi 10 to the power minus 7 Newton per ampere square. So only mu naught multiplied by the 4 pi here. And mu naught upon 2 pi. This one is mu naught upon 4 pi 10 to the power minus 7. So mu naught upon 2 pi, this becomes 2 into 10 to the power minus 7 Newton per ampere square. ध्यान से सुनिएगा इसको. Mu naught upon 4 pi 10 to the power minus 7 Newton per ampere square. So mu naught upon 2 pi is 2 times of it. So this becomes 2 into 10 to the power minus 7 Newton per ampere square. And under this topic, our aim is to find unit and dimension of mu naught. So from here you can say unit of mu naught Newton per ampere square. So unit of mu naught, we can write here unit of mu naught, unit of mu naught is equal to Newton per ampere square, and its dimension and its dimension you can write in Newton, unit of force, and its dimension is m l t to the power minus 2 upon ampere current a square. And when you will take this a square in the numerator or transpose this a square in the numerator, you can write m l t to the power minus 2 a to the power minus 2. So this one is the dimension of epsilon naught. So dear student, please all of you learn what is the value of mu naught upon 4 pi with the proper unit. Only mu naught and mu naught upon 2 pi, because when you will solve the numerical, then always you will use the value of either mu naught upon 4 pi or only mu naught or mu naught upon 2 pi. So be careful about this. Now there is some important note, and all these notes which I am going to give you is very very important here. And first you see, first point is what here? Actually Biot law हमेशा एक small current element के लिए use होता है. So Biot law is used for finding the magnetic field due to a small current element. So if finite size current conductor is given, अगर कोई finite size का current carrying conductor दिया हो, तो हम assume क्या करेंगे? उस पूरे finite size के कंडक्टर को हम छोटे छोटे small current element में assume करेंगे, और किसी एक एलिमेंट से जिस पॉइंट पे मैग्नेटिक फील्ड निकालना है वहां पे मैग्नेटिक फील्ड निकालेंगे. एंड then that formula is what here? dB is equal to mu naught upon 4 pi I dl sin theta upon r square. ये मैग्नेटिक फील्ड ड्यू टू ए स्मॉल करंट एलिमेंट, पूरे फाइनाइट साइज के करंट कैरिंग कंडक्टर में से हम जब स्मॉल स्मॉल पार्ट में इसको डिवाइड किए तो किसी एक एलिमेंट के कारण मैग्नेटिक फील्ड इतना है। तो फॉर फाइंडिंग द मैग्नेटिक फील्ड ड्यू टू होल कंडक्टर, पूरे कंडक्टर से निकालने के लिए क्या करेंगे? वी विल इंटीग्रेट दिस वन। सो B is equal to integration of dV. Integration of dV is what here? B, and when you will integrate it, so you will get here integration of mu naught upon 4 pi I dl sin theta upon r square. So in this way you can find out the magnetic field due to a finite size of current carrying conductor at any point P at distance r from the conductor. So be careful about this one. But Biot Savart lie is used for a small current element. At angle 0 degree or 180 degree from the direction of current, the magnetic field B is always 0. Always remember this. If you want to find, suppose this one is a current carrying conductor, this one, a current carrying conductor, and you are taking point P here, and when you will join any element through this point P, then it makes angle 0 degree, or when you will take here, then it will make angle 180 degree. It means if the angle between current and point where you want to find out the magnetic field is either 0 degree or 180 degree, then at that point the magnetic field will be 0. Why? Because in this case, when you will apply this Biot Savart law for the small current element, then their theta becomes 0, sine 0, 0, it means magnetic field 0. And when you will take 180 degree, then sine 180 is also 0. So for that point, magnetic field is also 0. For example, suppose this one is a current carrying conductor. Suppose this one is a current carrying conductor carrying a current I. And you know, Biot Savart law is applicable for any shape of the conductor. उसमें कोई restriction नहीं है कि नहीं Biot Savart law के लिए यही shape होना चाहिए, ऐसा कोई जरूरी नहीं है. Suppose our aim is to find the magnetic field at this point P, and one more point is here P dash. So when you will extend this one current direction I, so when you will extend it, it means all those points which lies along this current carrying conductor, means either P or here A or here B, at all these points theta is 0 degree, and when theta 0 degree, the magnetic field will be 0. In same way, at all these points below it, you can say direction of current here, you are taking the point here, so this angle is 180 degree, sine 180 is also 0. एक चीज बस याद रखिएगा, करंट कैरिंग कंडक्टर को एक्सटेंड करिए, उस पे जितने भी पॉइंट आते जाएंगे दोनों तरफ, उन सभी पॉइंट पे मैग्नेटिक फील्ड हमेशा 0 होगी. Third point, the current due to a current element at any point, the magnetic field will be maximum when theta is equal to 90 degree. It means when the point where you want to find out the magnetic field, जैसे ये करंट कैरिंग कंडक्टर है और हमको इस पॉइंट पे मैग्नेटिक फील्ड निकालना है, तो ये पॉइंट P और इस कंडक्टर से जब हम जो लाइन बनाएंगे, जब इसके साथ एंगल 90 डिग्री बनाएगा, then at that case theta becomes 90 and sine 90 is 1 and the maximum value of sine is 1. So at that point the magnetic field becomes maximum. जैसे ये करंट एलिमेंट है, मान लीजिए I, ये पॉइंट हमने P लिया और ये पॉइंट P यहां से ये एंगल मान लीजिए 90 डिग्री बना रहा है, तो at this point the magnetic field will be maximum. Now the relation between mu naught and epsilon naught, means our aim is to find what is the relation between mu naught and epsilon naught. So here all of you know mu naught upon 4 pi is equal to 10 to the power minus 7. And 1 upon 4 pi epsilon naught already have discussed in Coulomb's law. 9 into 10 to the power 9. So you can say here mu naught epsilon naught is equal to, we can write here mu naught upon 4 pi into 4 pi epsilon naught. हमने इस चीज को इस फॉर्म में लिखा, इस तो ठीक है, क्योंकि 4 पाई से 4 पाई कैंसिल होगा, फिर म्यू नॉट एप्सिलॉन नॉट हो जाएगा. बट यू नो म्यू नॉट अपॉन 4 पाई इज 10 टू द पावर -7 न्यूटन पर एम्पियर स्क्वायर इनटू 4 पाई एप्सिलॉन नॉट 9 into 10 to the power 9. Already you know the value of 1 upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught 9 into 10 to the power 9. So 4 pi epsilon naught 1 upon 9 into 10 to the power 9. And when you will take it the proper unit, then you will write the unit of this one is Newton per ampere square, and the unit of this one is also Newton meter square per Coulomb square. So you can also write the proper unit. And finally you can write this is equal to 1 upon 9 into 10 to the power -7 when you will take here, then 10 to the power plus 7. So this becomes 10 to the power 9 plus 7 is how much here? 60. And now you can write here mu naught epsilon naught is equal to 1 upon 3 into 10 to the power 8 whole square. Mu naught epsilon naught at place of 3 to 10 to the power 8 we can write speed of light. So 1 upon c square, or we can say here c square is equal to 1 upon mu naught epsilon naught, or c is equal to 1 upon root mu naught epsilon naught. This is the relation between mu naught and epsilon naught. Dear student, always you learn this relation. This is very useful relation, especially for finding the unit and dimension of 1 upon root mu naught epsilon naught. याद रखिएगा 1 upon root mu naught epsilon naught का यूनिट मीटर पर सेकेंड, क्योंकि ये c के बराबर है, एंड यूनिट ऑफ स्पीड मीटर पर सेकेंड. So 1 upon root mu naught epsilon naught, its unit is meter per second. Dimension of 1 upon root mu naught epsilon naught, LT to the power -1. So suppose if anybody asks you what is the dimension of 1 upon root mu naught epsilon naught, तो ये मत करिएगा कि म्यू नॉट का यूनिट लिखें फिर एप्सिलॉन नॉट का फिर मल्टीप्लाई करके इसमें ना, दिस इज नॉट वे. डायमेंशन ऑफ 1 अपॉन रूट म्यू नॉट एप्सिलॉन नॉट, ध्यान करिए यहाँ पे c इज इक्वल टू दिस वन, so dimension of c is LT to the power -1 is this right. Dimension of root mu naught epsilon naught, so 1 upon this one you will say, so this becomes L to the power -1t. Dimension of mu naught epsilon naught, simply you can say L to the power -2t square. So in this way you can find out the dimension directly of mu naught epsilon naught, or 1 upon root mu naught epsilon naught. Now the next topic is comparison of Coulomb's law and Biot law. Means how can we compare this Coulomb's law and Biot law? Under this, what is the similarity between these two Coulomb's law and Biot law, as well as what is the dissimilarity here? तो similarity क्या समानताएं हैं? तो first one, Coulomb's law is used for finding the electric field due to a distribution of charge. Coulomb's law is used for finding the electric field due to distribution of charge, while Biot law is used for finding the magnetic field due to a current element. This is the first similarity between the Coulomb's law and Biot law. According to Coulomb's law, the magnitude of the electric field due to a charge dq at distance r from it, that one is given by dE is equal to 1 upon 4 pi epsilon naught dq upon r square. This is the magnitude of the electric field due to a charge dq at distance r from it. While by using the Biot law, due to a current element IDL, the magnetic field at point P, which is at distance r from it, the magnitude of that magnetic field dB is equal to mu naught upon 4 pi I dl sin theta upon r square, where theta is the angle between that current element dl and line joining that point टू द करंट एलिमेंट. जिस पॉइंट पे निकालना है मैग्नेटिक फील्ड, उस पॉइंट को इस करंट एलिमेंट से मिलाने पे जो एंगल बनेगा वो एंगल है ये थीटा. सो दिस वन इज व्हाट हियर, इलेक्ट्रिक फील्ड ड्यू टू ए चार्ज dq at distance r, and this one is magnetic field due to a current element idl at distance r. It is given by dB is equal to this one. And third point, you can say only कि here electric field inversely proportional to r square. Magnetic field due to a current element is also inversely proportional to r square. It means both Coulomb's law as well as Biot law, both is follow the inverse square law. So these are the similarity between Coulomb's law and Biot law. Now, what is the dissimilarity between the Coulomb's law and Biot law? So first dissimilarity is what here. In this Coulomb's law, this charge dq is a scalar quantity, while in Biot law, this term idl is a vector quantity, and the direction of this idl is same as the direction of current. So this is the first dissimilarity between the Coulomb's law and Biot law. And the second dissimilarity is what here? Second dissimilarity, according to Coulomb's law, the direction of the electric field is always along the line joining that charge dq and the point where the electric field is to be calculated. इसका मतलब दूसरी डिसिमिलरिटी क्या है कि इलेक्ट्रिक फील्ड का जो हम डायरेक्शन निकालते थे हमेशा जो चार्ज dq है वो, और जिस पॉइंट पे हमको इलेक्ट्रिक फील्ड निकालना वो पॉइंट को मिलाने वाले या ज्वाइनिंग लाइन के ही अलाउंग होती थी इलेक्ट्रिक फील्ड. But in the case of the Biot law, the direction of the magnetic field at any point P is perpendicular to that current element as well as it is perpendicular to the line joining that current element to the point P. ये लास्ट वाला पॉइंट बहुत याद रखिएगा. The direction, according to Biot law, the direction of the magnetic field due to a current element at any point is always perpendicular to the current element as well as perpendicular to the line joining that current element to the point P. तो इन दोनों के perpendicular होगी हमेशा magnetic field. ये दोनों क्या थी? Dissimilarity between the Coulomb's law and Biot law. And in the previous video already I have discussed कि how can we find the direction of the magnetic field. क्यों? क्योंकि Biot लॉ में जो हम निकाल रहे हैं मैग्नेटिक फील्ड ड्यू टू ए करंट एलिमेंट dB is equal to mu naught upon 4 pi I dl sin theta upon r square. इससे हम निकाल सकते हैं मैग्नेटिक फील्ड का मैग्नीट्यूड कितना है ड्यू टू ए स्मॉल करंट एलिमेंट. लेकिन हमेशा मैग्नीट्यूड के साथ साथ डायरेक्शन निकालने के लिए क्या करेंगे इसका? तो ऑलरेडी आई हैव गिवन हियर राइट हैंड पाम रूल. और राइट हैंड पाम रूल में मैंने बताया था कि हमेशा अपने right hand के these four finger you take together and this thumb both are perpendicular. जिस हमेशा thumb should be point out in the direction of current. ये हमेशा करंट के डायरेक्शन में रखिएगा. इन चारों फिंगर को एक साथ उस पॉइंट की तरफ रखिएगा जहां पे मैग्नेटिक फील्ड का डायरेक्शन निकालना हो. तो जिधर आपका पाम है इस पाम के परपेंडिकुलर जो भी है, मतलब अगर आप पुश करेंगे तो ऊपर की तरफ कर सकते हैं, जिसका मतलब यहाँ पे मैग्नेटिक फील्ड ऊपर की तरफ है. अगर ये ऐसे आता है तो मैग्नेटिक फील्ड नीचे की तरफ है. तो इन दिस वे यू कैन फाइंड आउट द डायरेक्शन ऑफ द मैग्नेटिक फील्ड बाय यूजिंग द राइट हैंड पाम रूल. लेकिन हमने आपको एक तरीका बताया था कि इफ यू वांट टू फाइंड आउट द मैग्नेटिक फील्ड ड्यू टू ए करंट कैरिंग कंडक्टर, तो ऑलवेज यू मूव इन द डायरेक्शन ऑफ करंट. हमेशा आप अपने आप को एज्यूम करो कि हम डायरेक्शन ऑफ करंट में मूव कर रहे हैं. और जिस पॉइंट पे मैग्नेटिक फील्ड का डायरेक्शन निकालना है, अगर वो पॉइंट आपके राइट हैंड साइड में पड़े तो हमेशा मैग्नेटिक फील्ड परपेंडिकुलर टू द प्लेन ऑफ पेपर डायरेक्टेड डाउनवर्ड होगा, और अगर वो पॉइंट आपके लेफ्ट हैंड साइड में पड़ेगा तो परपेंडिकुलर टू द प्लेन ऑफ पेपर डायरेक्टेड अपवर्ड होगा. This is the best method for finding the direction of the magnetic field, and I hope it is very easy for all of you. So dear student, today you go through this one here, what topic or what point I have discussed regarding to this one, and in the next video I will give you the application of Biot Savart law. Thank you.